So in last, obviously we have read about the atomic, and molecular masses. So if I ask you that, do you calculate any atom mass of atom? It is not possible to calculate the actual mass of atom, because atom is a very small in size. So what we are taking, that we are calculating the relative atomic mass, right? We are calculating the relative atomic mass, and that time we are taking that standard one reference we have to take, and therefore that reference what we are taking, that carbon 12 isotope. What we are taking, carbon 12 isotope. Though you know about these things, but I have to tell, yes, I have to tell this one, so we can again recap all the things, and again we can read all the parts. Okay. So whenever I talk about the atomic mass, we are using the one unit that is called atomic mass unit, that is represented as a AMU unit, atomic mass unit. Now what does it mean? What does it mean, that atomic mass unit? Atomic mass unit is nothing but is a mass exactly equal to 1/12 mass of one carbon atom. Atomic mass unit, what I am telling, again I am repeating, the mass exactly equal to 1/12 mass of carbon 12 atom. 1/12 mass of one carbon 12 atom. And what is the, if I talk about that, what is the value of 1 AMU in the gram? It is a 1.66 into 10 to the minus 24 gram. That is a very important part, that whenever we need to convert 1 AMU to gram, you have to multiply with this with 1.66 into 10 to the minus 24 gram. So sorry, here one picture you can see has been given, that if I talk about that, now one element symbol has been there, and already a lot of things are mentioning here. So you can say, sir, what does it mean and why it is been given here? So first of all, in the periodic table you can see there is a coming from the periodic table. So how to read the periodic table, it is also very important. So in the periodic table, that it is a symbol of the gold, you can easily understand, it is a symbol of the gold, and in the left side the atomic number has been mentioned. Atomic number is not equivalent to atomic weight. Atomic weight generally present in the right side corner, that is the 196.79, that is the atomic weight of that gold, and that you have to understand. Next part was the electronic configuration, name and all the things are there, but just remember that the atomic weight generally present in the right side corner, and in left side corner atomic numbers should be present. So these things are present. Now I talk about the molecular mass. When I talk about the molecular mass, so you can easily understand about that, that when a molecule is forming, that obviously our molecules are forming from the atom. So if you are summing up all the atomic mass, then you will get the molecular mass. Okay, now I am giving some example of atomic masses. The general atomic masses, you should remember for these, that hydrogen has a mass 1 AMU. Hydrogen mass 1 AMU. Nowadays AMU is replaced by the micron sign. Suppose I have the nitrogen. So nitrogen, what is the mass of the nitrogen? 14 micron, or you can say 14 AMU. If I have the oxygen, it is a 16 micron. If I have the sulfur, it will be the 32 micron. Similarly, if I try to remember the most of the atoms, that atomic mass unit. Now obviously when I talk about the atomic mass, that is the represented the micron unit. One atom mass is a 1 micro, that one atom of hydrogen has 1 micron or 1 AMU mass. Few example more I can give, that if I talk about that calcium, it will be the mass of 40 micron. If I talk about that chlorine has 35.5 micron. Now here the question is coming, why chlorine has coming the fraction value? Why chlorine has coming fraction value? Because in our world chlorine present as a different isotope. Obviously every isotope is not equally distributed. Chlorine has a two isotope, one is a chlorine 35 and 37. Chlorine has a two isotope, chlorine 35 and 37. I am writing here 35 and 37, and their percentage is like that 99% of chlorine 35 and chlorine 37 should be that point something is there. I am not exactly knowing the value right now. So when we are calculating, we are getting a average atomic mass. Generally we are calculating average atomic mass, because generally every element has an isotope, and if isotope, we have to count that isotope, then obviously we have to calculate the relative average atomic mass, and that is why the chlorine got that average at that average value, that is the 35.5 micron. So now if we are moved to the molecular mass and molecule formula mass. So as I told you that about the molecular mass, that molecular mass is the sum of the atomic masses of the element present in a molecule. It is obtained by the multiplying the atomic mass. So if I obviously here you can see that the molecular weight of water has been given, and you can see that atomic weight they are mentioning 1.007 exact value are there taken. But according to my thinking, obviously we are not taking that so much decimal value, we are taking the whole number. If I talk about the hydrogen, you will take the value 1 micron. If I talk about the oxygen, you will take the 16 micron. But either exact atomic weight, that is the 15.999, and that is why we are converting into the nearest whole number, that is the 16.0, and we are getting the molecular weight of water 18 gram per mole, or you can say 18. One molecular mass, one mole, that if I talk about the water, what is the molecular mass of water, that is the 118 micron, you can say. If I talk about that, what is the gram per, if I talk about the molar mass, that time 1 mole of water contain 18 gram molar mass, you can say. What is the formula mass? So few substance was there like sodium chloride. If I talk about the sodium chloride, here NaCl, for NaCl, KCl, all the ionic compound, they are generally present as a aggregated substance, Na plus Cl minus, like positive cation and negative cation, they are aggregated part, they are not forming normal compound. So that time we are using the word formula mass, but the method of calculation the formula mass is similar to the molecular mass. So it is nothing that if I talk about the what is the formula mass of sodium chloride, so you know that sodium has the value 23. Sodium has the value 23 gram. I am just taking the gram molecular mass. If I talk about the chlorine, already you have learned about this 35.5 gram. So if I asking you that okay, what is the formula mass of sodium chloride, you can easily say that is nothing but 58.5 gram. 58.5 gram. So these things you have to understand. Now suppose I am giving one more example, that I have I have CO2. So what is the molecular mass? So you can easily say that 12 plus 32, that 2 oxygen is there, that is a 2 into 16, that is a 32 gram, and ultimately we are getting that 44 gram for carbon dioxide. Obviously again if you are going to the little bit higher, that okay, what is the molecular mass of calcium hydroxide, then how do we calculate this one, that calcium has a 40, that atomic mass of calcium is 40. Now 2 hydroxyl molecule is there, oxygen is 16 plus 1 hydrogen, that is 1. So 17 to total, ultimately it will come that 74 gram. So like this you have to calculate the molecular mass, and it is a very important that you have to know the atomic masses, so you can easily calculate the molecular masses or formula mass. Suppose one more example I am giving, asking you that I have the calcium, I have the sodium nitrate, okay, or nitric acid. We just take an example of nitric acid. What is the molar mass, or just you can say that molecular mass of nitric acid? So 1 plus 14 plus 3 into 16, 3 into 16, because oxygen has the atomic mass 16. So what you are getting, that 16 into 3 is a 48, 48 plus 14, it is coming that 62, and 163. So we are getting that nitric acid has a value 63. Like these you have to solve all the egg problems, and by this way you can easily get an idea about the molecular mass and formula mass. Now we are going to the next concept, mole concept. It is also a very important concept we have to know. 1 mole is the amount of substance that contains 6 Avogadro number of elements. We have read about this one. Okay, or you can, in another word, you can say that 1 mole is the amount of substance that contain as many particles as there are atoms in exactly 12 gram of C12 isotope. That is the number, that say 6.022 into 10 to the 23 entities. So whenever I talk about the 1 mole of 1 mole, that means it has this much number, and you know that SI unit of amount of substance is known as a mole. That is why the mole concept is very much important. Okay. Now in the picture you can see one thing has been given. If we convert the number of moles into the volume, then what we have to do? We have to multiply with the by 22.4 liter. That what does it mean? Now according to the mole concept, when we are calculating, we are getting the value that if 1 mole of substance at STP contain 22.4 liter of substance. That is the very important. This line here is given. Under STP condition, 1 mole of substance contain a constant volume 22.4 liter, or you can say 22,400 ml. So 22.4 liter. So if I talk about the 1 mole of substance, it contains this much volume, and if I talk about that how much entities are present, then it is called that 6.022 into 10 to the power 23 entities. That is called Avogadro constant. That is called the Avogadro constant. I am writing in a symbol formula Na. Sometimes it is also represented as a Na. So these things are present here. Okay, suppose I am giving one example also. I have the 1 mole of oxygen. I have the 1 mole of carbon dioxide. 1 mole of carbon dioxide. I have the 1 mole of ammonia. I have 1 mole of nitrogen. Just give some more example. 1 mole of that nitrogen. So if I am telling that, okay, what are the how much entities they present? So you just tell that Avogadro number of entities are present in 1 mole. See, if the word 1 mole is there, that means that much number entities should be present. Whether it could be a molecule, whether it can be atom, whether it can be ion, anything. If 1 mole term is there, that means it has Avogadro number. So with this, we are concluding our class. Again, we will meet with the new concept, new topics. Till then, take care. Jai Hind.